Hey guys, everything CNC here. Today I wanted to do a little topic on grooving. I got some people requesting for grooving and threading. So I'm going to try and do the 4 major grooving toolpaths as quick as I can. I already showed you how to set up a page, a blank page, and then fill out a couple of informations as far as edge facing and bar out. So I'm not going to do those again. I'll just go over it briefly. I apologize for the quality and the huge delay in shooting any more videos, but until I get my new camera, should be here in a couple of weeks, I'm going to go ahead and do this for you. Okay, so we have just a basic cylinder, 4 inches in length and 2 inches in diameter. We're going to start off with a raw stock of 2.5 inches that we're going to turn down. These are the 4 grooving types. I'm going to go ahead and go over them, and I'm just going to make up a fake thread here. I'll say, what is it here? 1.5 10 or 1.5 12, whatever you guys want to do. We'll go ahead and go over it just to show you the basic threading toolpath. And then another video, we'll go ahead and do some ID turning, boring, and stuff like that. But I'm going to see how I'm going to lay out this for future videos. So for now, we have our aluminum here. Just put down whatever you want. 2.5 inch diameter raw stock. Okay, so that's going to be the starting point for all our X moves. Don't worry about the inside. We don't have a hole in there already on the fixture. Damn, my fingers are greasy. Hopefully it doesn't smudge it up too much. Our length is 4 inches, but remember, you got to add extra material for your facing operation to clean up the raw stock on the face, and then you got to add, if you're going to part off, the thickness of the tool and how much material you're leaving extra. Otherwise, it'll give you an error and say, hey, you want to machine more than what material you gave me. We're going to finish with aluminum. I always finish 5 thousandths on the X, and I finish 5 thousandths on the Z, which is the face of the material, and I always remove typically 25 thousandths from the face of the material if it's a bar stock. So we have our edge face under unit number 1. Okay, we're going to start with a roughing surface feet of 1200, and we're going to finish with the surface feet of 1200. This is just for an example. Okay, you could definitely take heavier cuts, but you know, for me, I'll do 10 thousandths in this video of depth step over, and 10 thousandths step down for a facing, and 25 thousandths step over for depth of cut. Our roughing tool is 1 and finishing tool is 1. Our starting point for X is going to be at the diameter of our stock or more. Okay, you never want to start below the stock, otherwise you'll crash the tool on X. We're going to go from a positive X 2.5 to an X of 0, which is center of the part, and we're going to start 25 thousandths away from the material and finish at Z0, which is the face of the part, and we're going to leave a finishing of 3 thousandths per step over, per revolution. And we're going to bar out 2.5 inches starting point on X, and we're going to start at Z0 because we already finished our face to Z0, so we no longer have to leave an extension of stock material. And we're going to do 1200, 1200, 10 thousandths step over per revolution at a depth cut of 25 thousandths. So every time the part rotates, we're going to step over 10 thousandths, digging into the material 25 thousandths deep. Okay, that's how that goes. 1 and 1 are going to be my tool numbers again, and it's going to be aligned with the chamfer of 5 thousandths. So just on the very front end, we're just going to kill that corner. I use it as deburring, as probably 90% of all other machine shops do. They throw like a 5 thousandths around it. You'll find. And we're going to finish it to a diameter of 2 and a length of 4 inches. Usually you're going to want to leave material more for when you flip it around and you face it. You'll have 10 thousandths extra material there, and to pass the cutter radius, past the point of where you want it to machine finish to, and 3 thousandths step over. So let's just get right into the grooving. Okay, for the first groove, we're going to go ahead and do this guy. You're going to select the number that looks like that. Okay, we're grooving to a total diameter of 1.75. Okay, and that's from the inside there. So if you were to take calipers and you were to measure it, that's the number you would get. That's how you program these guys. Now, these ones get programmed from Z0 onto this face, or when you look at it, it's going to be up here. Okay, so from Z0 to the first part of the face. And how you can double check that is going into the mode. We're going to say we're going to groove. It's going to be an outside groove. and it is number 2, okay? But if you ever get stuck, and sometimes I forget as well, click over one and click help, and that will display all the information you need. I mean, everything you need. It tells you your start point, your finish point. It gives you an example of pitch. It tells you what number and what correlates to what number and what shape, and it tells you, okay, if I program this guy, you are going to calculate from Z0, which is this guy here, back out here, and then when you tell it its width, it's going to calculate this direction, okay? So start, finish, and this direction. If you say a number 1, you're going to calculate it from Z0, and this is going to be your starting point, okay? From Z0 to here, and when you type in your width, it's going to work back in this direction, okay? So that's how that works. But right now, we are going to go ahead and do this guy right here, and it from Z0 to the front starting point is going to be 1.25, okay? So we're going to go ahead and click number 1. Oh, I'm sorry. This will mirror that side onto here. We are going to use number 2, okay? And it's going to be number of grooves. It's just going to be 1. If you were to put more than 1, you could tell it, hey, from here to there, I want to do like 5 grooves, and it'll do the pitch just like a thread, okay? Grooving pitch, just hit enter. Don't need to worry about it. The width of the groove is 0.250, okay? The finish, we'll just say 0.003, and that's how much stock it's going to leave to take off. Surface feed for that, we'll say 500 and 500 finishing. And then feed rate per rough cut for revolution, we'll say 0.003 as well. You can do whatever you want, find out what works best. Material reacts widely different from material to material, so you'll just have to look that up in a machinist handbook or figure it out. Rough max depth of cut is going to be 0.025. We'll just go, you could say way more than that, but like I said, for example purposes, this is what we're going to do. And our roughing tool number, we'll say 3, because that's what it is on the machine here. And I'm sorry, 2 is what it is, and 2. I have to say the actual tool in order to see the back plot, because it calculates all the information from the tool. So if you do not have the tool set up, or you incorrectly select the tool number, and you don't have it configured in the computer for your tool offsets and stuff, it won't show you the correct tool path, or it will give you an error and just won't show you anything at all. So you got to make sure when you select the tool, it already has to be defined in the computer. You don't need to actually have the tool in the machine and set up, but you need to have it defined. And that goes to this page back here, tool data, and we select number 2. You say groove out. I have a 93 thousandths thickness cutter, and each side of the cutter is going to be 4 thousandths in radius, okay? So that's what I mean by that. To go back, go program, and then hit program one more time in order to edit. And let me scroll back down. Okay, our radius, we don't need to worry about that right now. Our starting point on X is going to be the 2 inches that we turned it down to up here. Started at 2.5 to 2. Okay, our starting point on Z is going to be, let's see here, it's 1.25 from the face to back here, because if you remember when we clicked help, it said that we start from that direction. And I'll go back and show you that real quick. Click help. Oh, whoops, wrong section here, program. So when you go over and you select, you see these, you just click over and help for that information that says number 2. Starting point is here. Start point, finish point. So wherever I start, wherever I finish, and then I hit the menu. Oh, let me close that. Okay. And now we'll go ahead and go back to the program here. So 1.250. Okay. Final point on X is going to be 1.75. That is the diameter of the finished groove. So that is this guy, from the inside diameter of where you would measure the calipers, or hopefully blade mic, be a little bit more precise. And then the final point on Z, to get an image of the angle. So you start up top, and then wherever you finish. If you finish on the Z point the same as here, it'll just be a straight box. If you wanted to finish over a little bit, we'll say we started at 1.25, let's say 1.35, okay? So now we're gonna start and finish at a little bit of an angle. Don't worry about the corner radius and the angle. You could say an angle, and it'll calculate it automatically for you. But feed rate per rev, we'll say 0.003, okay? And there you go. So let's check it out. Program, toolpath, part shape, check continue. Oh, whoops, check continue, there we go. Roughing, finishing, and now it's stepping in and doing an angle and finishing, okay? Let's go ahead and toolpath erase, check continue. Once it gets close, I'll go ahead and, okay. Let me zoom in, scale change. And then I'm gonna say 0.5, okay? Part shape, check continue. Once it gets close here. Okay, so it's going down, then it's stepping over and cutting more relief. Then it's gonna step over, cut more relief, okay? And now it's gonna come in and finish. Okay, here it goes. There you go. So that is your start point. That is your finish point. Remember, we started at the distance from 0 to here, and then for this finish point, we started at a further distance from 0 to there. We defined the X, the diameter, from this top to the other top, or the bottom, and then we gave it a step, a width, when you describe the width from here to here, and that was 250. So that's how that group goes. Now, program. Let's go ahead and go to the next one. Program, groove out, and we're gonna say number 0. Number of grooves, we're just gonna say 1. Grooving pitch, we only have 1, we don't need to worry about pitch. The width of this groove is 0.275, okay? Finishing 500, okay? And our finishing feed rate per rev, 0.003. Our max depth of cut, we'll say 0.025. And our tool, once again, is going to be number 2. Okay, we'll put a radius at the top of each corner on here. Actually, we'll just put a chamfer, 0.005. Okay, our starting point is going to be 2 inches again. And our Z point now, when we do this one, we calculate it from the back side. So we take from the front all the way to the back side. If you look in the help menu, that's what it says. Don't ask me why, it's how they made this program. So our Z point is going to be 2.125. Our final X point is going to be the minimum diameter that the groove goes down to, which is 1.5. Okay, and our Z point is going to be the exact same thing because it's a straight part. So we're going to say 2.125. Okay, so our start point and our end point is a vertical line, so we just say it's the same Z. Angle, don't worry about taper, there's no taper. Our feed rate per rev, 0.003. And now let's check it out. Program, toolpath, part shape, check continue. Now you should be able to see it. Okay, it's going down. It's gonna go down again. Wonder if I can just hold it. No, okay. Check continue, so it's gonna keep going, roughing it out, and then it's gonna just leave it there, okay? There's no finishing operation on this one. Okay, you're gonna have to do a different type of tool path, which could be this one if you're to do straight, or you could go to another program that would do this guy. Just don't put any taper on it. It'll rough it and it'll finish it. So we'll go ahead and do the next one. Program, groove. Oh, let's get this in focus. I haven't really been paying attention to that. I hope it's been in focus. Okay, so we'll do groove out, and the next one we're going to do is a number 3. Okay, number of grooves, we just have 1. Pitch, don't worry about it. Width of groove is going to be 0.506. Finish 0.003, and we're going to do a 500 surface feed, 500 surface feed for finish. Now this one has a finish, so we're going to do 0.003 per rev. Depth 0.025, just for an example, and we're going to have tool number 2 again. Okay. For a chamfer, on one side it's only going to chamfer, and that's the far side. We'll go ahead and put 0.005. Starting point and X is going to be 2 inches again. starting point in Z, this is measuring from the back side, the side closest to the spindle again. So this is going to be 2.854, 2.854. Oh, wow. 2.854. And the X point on this is going to be 1.652, 1.652. Z is going to be the same exact thing. Oh, actually, we'll make it go closer to the front. So we'll say it's 2. Let's say 750, okay? And feed rate 0.003. And let's go ahead and check it out now. Program, toolpath, part shape, check continue. So there's the taper. We started at this Z and we moved it closer to the origin, so that's why it has the taper. It's running, now it's roughing, and now it's going to come back and finish the bottom. The one thing to note is that when you do these angled, these two angled ones, it does not finish this backside wall, okay? Those don't get finished. It just goes, finishes here, goes to there, and rapids out. So if you didn't have an operation that was needed for roughing, if you had an operation that wasn't needed to have a nice finish on the back, it's great, it's real quick. But if you need to have a nice finish on the back, you're going to need to do something like this, and then throw this guy in there, or throw this guy in there to finish up the backside face. So let's go ahead and move on to the last grooving toolpath that I'm going to show you, and that is going to go back, program, and hit program one more time. Remember to edit it, and we're going to say it's another groove, and then out, and what was the last one? It is going to be this guy. Now whatever you do from one side, it's going to replicate to the other. You're going to say it's one groove, pitch is nothing, don't worry about it, and the width of this one is 0.630. okay, that's from the top end to the top end, not the bottoms, okay? And our finish is going to be 0.003, feed rate 500 rough, feed rate 500 surface finish, for finishing, 0.003 per rev, depth 0.025 for an example, 2 for roughing tool, 2 for finishing tool. We're going to say 0.005 chamfer. Our starting point is 2.0. Finishing point is going to be 2.940, okay? So these ones get finished from Z0 to the front face, not the back ones, okay? So Z0 to the front face, you can click the help menu. Once again, to get to the help menu, you highlight the number that when you see these, click over one button, hit help, and it tells you, okay, so for this tool, starting point, finishing point, and width. Now, I'm not going to do a taper on this one. Actually, I will. Okay, I'll do a taper for you guys so you can get the example. Let's go back to the program, and go down. Z depth is 2.940, okay? Now, final X point, we have 1.566. Final point on Z. If we did 2.940 here, we need to add more in order to get a taper, but I'm going to do another way of programming it. I'm going to say final point Z is question mark, okay? So I'm going to have an angle, and I'm going to have it calculate for me. So I put, hey, I don't know the final Z point, but I know the angle, and it's going to be 30 degrees, okay? Taper angle 30 degrees. My finish feed rate is 0.003. And then let's check it out, see what I did. Program, toolpath, part shape. And, okay, so my angle was too steep because I just made up an angle. Let's go back, program, and we'll say that, it's 15 degrees. And then I got to replace this with the question mark again, and it's going to calculate it itself. Toolpath, part shape. Oh. Did it again. There we go. 60 degrees. There we go. Went the wrong way. Question mark. There we go. Okay. Now we're going to check continue. Okay. It's running it. And go through that guy. Now, with all the years I've been doing this, I don't know how to skip right to the stuff. If somebody knows how to, please let me know. Okay, so now it's roughing the center, and now it's finishing half and goes back to the other half and finishes half. So let's go ahead and zoom in, scale change. And this is one of my favorite ones to use, by the way. Here we go. Let's say, what are we at right now? It shows you right up at the top here, 1.3. So I'm going to say 0.5, and then part shape. I'm going to check continue, let it run through everything, and then once it gets close, we'll go ahead and stop this. So it's doing the other ones right now. Yeah, it's kind of a pain when you have a big program, though, too, to watch it. Okay, so check step. Okay, it's starting in the center. It looks a little offset, but that is not calculating the width of the tool. So the tip of the tool that touches the sensor is always the little arrow, and our thickness of the tool is going that way. So from here that way, it's 93 thousandths. So we actually are cutting dead center of the part. Okay, and then it's going to step over. It's going to do another cut, and then another cut, and then it's going to jump back to the center and start doing the other half, and then it'll finish that and finish the other half. And it's a really, really nice, very versatile type of grooving to do. That one, and then one of the angled ones on the corner, which are these guys here. Let me highlight it, program, go back, help. This guy, and then one of these. You'll find that you could use that combination in almost every single possible groove that you could do. Now, this is exactly the same on ID grooves, okay? You just tell it to start on the inside and then to what diameter, outer diameter. When you're doing the outside, you say start on the outside diameter and work your way into the inner diameter. It's just basic common sense. I mean, but it does take a little bit to figure out how to do it, and once you get to doing it, any machinist who's an actual machinist knows how to figure out shit and go from there. So here's a little jump start. I hope this helped, and let me know if I should do this in a different way, or if I completely suck at this and just get somebody else to do it. But I hope that me taking a couple minutes and showing you guys how to do something is good enough. Let me know, comment, subscribe, do whatever you guys do, and I'll see you guys later in another video.